Hello friends, in today's question, masses m1, m2 and m3 are connected by strings of negligible mass which passes over massless and frictionless pulley P1 and P2 as shown in figure. The masses move such that the portion of string between P1 and P2 is parallel to the inclined plane and the portion of string between P2 and m3 is horizontal. The masses m2 and m3 are 4 kg each and the coefficient of kinetic friction between the masses and the surface is 0.25. The inclined plane makes an angle of 37 with the horizontal. If mass m1 moves downwards with a uniform velocity, find the mass of m1 and second the tension in the horizontal portion of the string. So this is our figure. We have three masses m1 and m2 connected by a string, and the mass, it states that m1 is moving in the downward direction, and we are going to find out what will be the mass m1 and second the tension in the horizontal string, it means tension here. So let us draw all the relative forces. So from here we can say that m1g will be acting downward direction, and let us suppose there is a tension of T1 here, and there will be tension of T1 here also, and here let us suppose the tension is T2, and here also it will be T2. Okay, so this m2, it will be acting downward direction like this. This will be m2g, and this can be divided into two components. So this will be our 37. So we have the component in this which will be equal to m2g cos of theta. So this will be m2g cos of 37, and we are going to have this component which can be written as m2g sine of 37. Okay. And first of all we are going to find out what will be the mass m1. Okay, and it is given that our system moves with uniform velocity. Okay, so from here we can say as the mass m1 moves with uniform velocity, the net acceleration of the system will be 0. Of the system will be 0. Or from here we can also say that the net force will be 0. Let's write now the equations for all the masses. Let's write for first of all for mass m1. So we can say for mass m1, so this is its free body diagram. m1, the downward direction we have m1g, and in the upward we are going to have tension T1. Therefore we can say that T1 is equal to m1g. Let us this be equation 1. Now let's write for mass m2. For mass m2, and m2 is on inclined plane, Angle of inclination is given the 37, and this is our M2. So we are going to have M2G, two components. This will be 37. So this will be our M2G cos of 37, and this will be M2G sine of 37. And along this line we are also going to have T2 tension, and here we are going to have T1 tension. And the friction is also said that it will be present. So as M1 is moving in downward direction, therefore the block M2 will be moving up the inclined plane. So we are going to have frictional force that will be acting in the down inclined plane, and let us call that FR2. So we can write the equation of motion as there will be no acceleration. So we can say T1 is equal to FR2 plus M2G sine of 37 and plus T2. And there will be a normal also here. Let us suppose that is N2. Okay. So we can say our FR2 will be equal to the coefficient of friction and normal N2, and N2 will be equal to M2G cos of 37. This becomes mu M2G cos of 37. So then the equation comes as T1 is mu M2G cos of 37 plus M2G sine of 37 plus, and we are going to have tension T2. Let me call this as equation number 2. Okay, and now we write it for M3. So you can say for mass M3, so M3 is on the horizontal plane and it has a tension of T2. In the downward direction it is going to have, this is M3, M3G. Let us suppose normal is N3, and it is also moving towards right side in this direction, left side. So let us suppose there is FR3. So we can write that T2 is equal to FR3. T2 is equal to FR3, and we can write the equation for FR3 is equal to mu into N3. N3 will be equal to M3G, so we get this mu M3G. Therefore T2 will be equal to mu M3G, and let us call this equation number 3. Now using equation 1, 2 and 3, using equation 1, 2 and 3, we are substituting values from equation 1 and 2 in equation number 3. Okay, so equation 2, that is T1, and T1 is equal to M1G, so this will be equal to M1G is equal to mu M2G cos of 37 plus M2G sine of 37 plus T2. T2 is mu M3G. and here G cancels out throughout. Okay, so we can say that our M1 is equal to mu M2 cos of 37 plus M2 sine of 37 plus mu M3. Now we simply substitute the values. Mu is given as 0.25, so this is 0.25. M2 mass is given as 4 kg each. 4 cos of 37 is 4 by 5 plus M2 is 4, sine of 37 is 3 by 5 plus mu is 0.25, and we have M3, that is our 4 kg. We can say that our M1 will be coming equal to 4.2 kg. Okay. So this is the mass of M1. And last, it is said that tension in the horizontal portion of the string. Okay, so we already know that equation 3 is given as T2 is equal to mu M3G. You can say from equation 3, T2 is equal to mu M3G, and mu is 0.25, M3 is our 4, and G is our 9.8. So we can say that T2 will be equal to 9.8 newtons. So this is the tension in the horizontal portion of string. This is the tension in the horizontal portion of string. So this completes the question. Thank you.